Okay, so yesterday we spoke about finding slope formulas, and there's a video prior to this that you can check out. It's on the web page on chapter 2, but it says graph a global representation of the function and use the slope formula. I'm going to stop there. Later on in the test, you're going to be given a problem like this, and it's going to ask you to graph it by hand and explain how you're able to do it without the aid of your calculator. On this problem on the test, I don't care if you go to your calculator and just graph it, but I'm going to go through that explanation of that sprinter, intermediate runner, distance runner here again, just to show you. So this graph starts up at 4, and then I'm going to combine the linear and the quadratic term together here. We know it goes down, and we know it wants to look like an upside down parabola, which means it's cupping down. So as it goes down through here, I'm trying to give it that little bit of hint that it's cupping down. Can you kind of see that little curve? I could make it more severe if you want, but I'm trying to give it that cupping down, going down look. And then ultimately, to the right, it's trending down, cupping down, but ultimately to the right, it's going to turn and come back up. Now, I don't know. Maybe it doesn't get underneath here. Maybe it doesn't get underneath the axis. But what I know for this problem that's important is that we have a relative minimum right there. And then to the right, it's trying to cup down, and then it's also trying to go down. So it's going to come back down in a hurry. Something like that. Doesn't matter. I don't believe this thing actually even comes underneath the axis. We'll look at it later. Doesn't matter. I've learned there is a relative maximum here, and as you can see, that's what this is about. And here's where we're going to use the slope formula. So I'm going to label that as y prime slope formula, and this is what we talked about yesterday. If you missed that, again, the video is on the website on chapter 2. So the slope formula, I take y, and mechanically this is what I do. The people who are here should understand where these answers are coming from, but mechanically I'm going to take the 3 times the 2, get 6x, and reduce the 3 by 1. So that becomes 6x squared minus, I'm going to take this squared 2 times 1, 2x, reduce the 2 by 1 to the first, and then I'm just going to ask myself, hey, what's the slope of the rest of this stuff? Well, the slope of that line is minus 2. That's our slope formula. Okay. Now, if we look at the slope of this function, it's positive here, positive, 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 0. Negative, 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 0. Positive, 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 positive. We get to the relative max and min. When we get there, that's when the slope is 0. So use the slope formula to find the exact coordinates of the x value of the relative max and relative min. I want to know what x value makes this be 0. This is a representation of the slope at any point on here. If I want to know how steep this graph is at 6, I'm going to put 6 in here. And that's what the slope is at that point instantaneously. But I don't want to know that. I want to know when is the slope 0. Now, once this is an equation, we can do this here. Once this thing is an equation, I'm going to just treat it like an equation. The first thing I'd do here is divide both sides by 2. And then I'd check, does it factor? I promise you when we take the test, it will not factor. Tegan, could you close the door, please? It won't factor for us here. So x equals opposite of b plus or minus square root of, thank you, b squared 1 minus 4 times 3 times negative 1 minus negative 12 plus 12 all on 2a 6. So I get 1 plus or minus square root of 13 on 6. And that's saying these are the values that make the slope 0. Therefore, these are the x locations of where our max and our min are. I've got the x's right here. One of these goes here, and one goes there. And here is the understandable common mistake, yet it's still a mistake. The mistake is just to ignore the graph and say, well, 1 plus square root of 13 on 6, that's the bigger number. That must be the maximum. But this isn't a maximum because x is big. This is a maximum because y is big. In other words, the minimum is located to the right. The minimum value is to the right. The maximum value is to the left. So the minimum is the bigger of the x's in this case. 1 plus square root of 13 on 6. The maximum is to the left, so it's the minus 1 minus square root of 13 on 6. Okay. And now let's go ahead and graph this. Enter it in on your calculator. So we've got, don't enter the slope formula, enter the original function. 2x cubed minus x squared minus 2x plus 4. And you'll see, oh yeah, it didn't come even close to getting down to the axis. Doesn't matter for this problem. I've got a general shape. I know I've got a max. I know I've got a min. All right. It says you may use your calculator to round the y value to 3 decimal places. If on the test you put the x value to 3 decimal places, you're getting no credit for that. Because I don't want your calculator to give you that answer. So here we go. Second calc max. I'm going to get to the left of the max, hit enter, get to the right, hit enter, and I think we still have 1 or 2 people who are doing that. Oh, I'm going to do that again. Second, quit. I didn't want to stop on 0. Second calc maximum. Get to the left. Get to the right. For instance, there. And they're I think entering these guys right there, but it's saying guess. I don't know why it's saying guess right here. It should just be saying hit enter again for whatever reason. And we hit enter again, and the y value is 4.516 to 3 decimal places. Go ahead and find the min. And to 3 decimals, I get 2.7078. Now, I'm going to go ahead right here. I'm going to write that x value down. I'm just going to jot it over here. 0.76759 ... And this is just a really nice way to go ahead and check did everything work out the way we expected it to. So I'm going to go back to, this is an x value, and it's specifically the x value of our min. And I'm going to go ahead and take my minimum right here. Second, quit. I'm going to go ahead and take my minimum, the value, x value of my minimum, 1 plus second square root of 13 equals divided by 6. And there it is. So I'm feeling pretty good about that. My one, and I can do the same thing for the maximum. But the fact that this matches this, I'm feeling pretty good about this irrational number. That makes sense? Okay. So here's a problem you can try. Check with each other on this one, and I got more practice problems like this. This is the first 12 points of the major part of the test.